Hello, my name is Juan Alcala, and I'm going to be presenting an introduction to electronic warfare. So, a little bit about the motivation and background behind the electronic warfare systems, or EWs, which I'll be referring to it a lot as. The scientific motivation behind EW systems is the ability to utilize and exploit the electromagnetic spectrum to advance military usage. And due to this new age of warfare, relying a lot more on radar, advanced communication systems, and electronic devices, the ability to utilize the electromagnetic spectrum effectively is a major decisive factor in achieving military tactic advantage. Um, One application of this could be trying to counter threats such as GPS guided missiles by using jamming techniques to disrupt the enemy's ability to either communicate or even operate effectively. And if you see the picture on the right, that is a block diagram for a traditional EW system. And in the previous example, um, although you might want to jam the missile itself might have EW protection. So the downside of these kinds of traditional EWs is that these techniques are pre-programmed and predefined, meaning if the missile has a way to identify the hostile interaction, then the EW system used to try and disrupt the missile won't be effective at all. And this is kind of where the evolution of AI plays a huge role, as cognitive EW systems have the advantage to adapt to threats in real time and operate autonomously by making decisions on their own. Um, and then another fundamental aspect um, of the cognitive EW compared to the traditional is that the cognitive EW continuously monitors the electromagnetic spectrum to locate hostile or friendly interactions, opposed to the traditional one that is just static. Okay, a recent advancement in this is digital radio frequency memory, which is DRFM. And DRFM systems, they capture the incoming signal and they digitize it to be stored in memory. And this makes it available so the signal can be accessed at any time, which can be used to reproduce the original incoming signal precisely. This is extremely helpful and very useful because it provides an updated approach to EW protection. Thanks to the DRFM, the radar signal can be modified to create false targets, known as decoys, which are used to draw the attention of enemy missiles and protect the target from being hit. So that's one of the applications of it. And then the other use case of this or application would be that it's effective jamming techniques, since the original signal was stored and in memory, it can be copied precisely and mask the signal from enemy radars. So the enemy radar will not be able to differentiate it from a real or fake target, essentially just hiding its true intentions. And then finally, we reach future advancements. And this was really interesting, cyber warfare integration, because it's very, very new. And in theory, this can be done by merging radio frequency based EW with cyber attack techniques. And they're used to disrupt or manipulate data transmission. And the whole goal of this is to inject any type of malware on enemy networks. There isn't much information out there since this is very new integration, but it will fundamentally like transform how combat is conducted on the field digitally. Thank you.